Guys, again, a request. Whoever wants to, start the course, just get enrolled yourself as soon as possible so that we can start the actual syllabus, that we are supposed to start. Okay. Uh, please try to get enrolled yourself so that, you are getting proper links of Zoom and, classroom sessions where everything will be provided, the class notes, videos, and all contents. So please get enroll yourself. Hi Zishan, good morning.
Good morning.
Zishan, can you tell me something about yourself? We didn't get introduced to each other. So can you tell me whether you are a student or working or what is your background? Zishan?
Asking me?
Yep. Yeah.
Yeah, yeah. I'm working experience. I have experience.
Okay. Can you briefly tell me like on what profile you are working and how many
Yeah,
years?
I'm working as a Pega developer.
Okay, in Pega. Good.
Yes,
So you are upgrading to data science, right?
yes, exactly. I'm trying to adapt new technology. Like,
Okay, Zishan. Got it. Thank you. Yeah, we'll give one more minute and then we'll start with our session. So this will be our today's agenda. We already covered in brief like what is an artificial intelligence. Then we spoke about what is data science and the basics of data science. Then yesterday we have discussed in brief about what is a agent, what is AI agents, and what are agentic AIs, what is the importance of them in artificial intelligence. Then we also have gone through a demo showing a small demonstration about how automation will be done using a AI agent. Okay. So today we will be covering machine learning as part of the data science. We all know machine learning is one of the component of the AI. Okay. So in today's session we will discuss briefly about what is machine learning. We'll just get an idea of what is what. Then we will see what actually or where does exactly the machine learning fits in AI context in the machine learning, and then what are the types of machine learnings that we have that we are going to use for our projects, and then we will discuss about what are the different applications which are using machine learning. Okay, then there is something called as machine learning life cycle, using which we'll look out an end-to-end example. Then, if time permits, we'll check on machine learning pipeline. Okay, great. So let us start with what is a machine learning. Today we will see the. Uh, please mute Ramakrishna. I'm getting background noise. Yeah, thank you. So we will keep things very simple because we are at the beginning stage, right? We'll just try to understand, briefly what is what. We'll take very simple examples and try to understand. From there, we will start and slowly we'll gradually as we grow, we'll take in depth the concepts of machine learning. But for today, just we'll try to understand what exactly is a machine learning, where it fits in the context of artificial intelligence. So as per the definition, right, what is machine learning? Machine learning is a way of teaching the computers to learn patterns. Okay, I will do one thing. Teach computers to learn patterns from the data instead of explicitly programmed. Okay, we will understand this statement first. So what we are doing is using machine learning, we are training the machines. Okay, we are training our systems. So in traditional methods, before machine learning, how we used to train the machines is we used to write statements, conditional statements. Okay. So if this is the condition, do this. If this is the condition, do something like this. Okay. Now, using machine learning, we are training the machines to understand the patterns. What exactly it means? For example, we recognize the objects, right? Just understand using our own example. Okay. When we see an object, we will recognize. Okay. This is a keyboard. Okay. This is a mouse. This is an apple. Okay. This is a fruit, or this is a table, a chair. So how we are understanding that this object is so and so, because since childhood we are observing the objects. Okay, since childhood we are getting idea to be known that okay, this is called as apple, this is called as a table, this is called as a chair. So slowly our brain is tuned, our brain is trained, okay, to understand these objects. That is how today we'll recognize the objects, right? The same thing, we are training the machines to understand the patterns using data. Okay, very simple. Okay, for example, just understand, like you are training a small kid. What we will do initially, we'll show them certain pictures. Okay, we'll show them, "See, this is apple. Okay, apple will be red and it will have smooth surface. This is mango, this is another fruit. Okay, this shape is something different." So we'll train them, right? We'll train them step by step. Same thing we are performing on the machines. And how we are doing that? We are doing that by feeding the different types of data. Okay. So ultimately, what are machine learnings? Machine learnings are nothing but mathematical equations. At the core level, machine learnings are nothing but they are mathematical equations. So whatever requirement we have today, we will provide the data to the machine learning algorithms. They are mathematical equations. What is an equation? What is the equation? What is the expression? Let me give one example here. Can't I open? Open. Give me a minute, guys. Okay, something is wrong. 1 minute. I want to open Notepad. Okay, for some reason my okay, got here. Okay, right. So ultimately, what are machine learning? Machine learnings are nothing but, or machine learning algorithms are nothing but they are mathematical equations. At the core level, they are nothing but mathematical equations. All machine learning algorithms are nothing but mathematical equations. They are completely depend on maths, which also uses statistics. Okay, when I say mathematical equation, what exactly? For example, we'll say y is equal to mx plus c. We all know, right? This one. This is called as an equation. Particularly, it is a line equation. Okay. Now, when I say we are training the machines using the data, is nothing but simply we are finding the value of this y using this equation. Suppose y is the value which I want to find, right? What we do usually, we will try to solve this particular equation. Let's not discuss in detail. Okay, just try to get an idea. Okay, what actually machine learnings are doing. So using a machine learning algorithm, we are trying to solve a problem. This equation you might have seen, right, in our school days. This is a line equation. So whenever we want to resolve some expression, for example, say area of a square, okay, to resolve this problem, what we do, we'll have a formula, okay. So that expression is nothing but a machine learning algorithm. So what we do, we will train the machines, we'll provide the data, and we'll train them, and we'll try to get the output of the required results. Okay. So where exactly machine learning fits? So we have earlier seen this diagram. Okay, this is a Venn diagram of the artificial intelligence and data science, how they are correlated together, what are the different components of artificial intelligence, and how data science is mapped across the all different components of artificial intelligence. Okay, so basically artificial intelligence is a bigger umbrella in which we will have machine learning as a subset. Then inside machine learning, we have something called deep learning. So I just now told you, right? Machine learnings are nothing but they are algorithms. Same thing, deep learning will also have advanced algorithms. So for a data which is very simple, which you want to train to a machine using a simple data for a simple cause, we will use machine learning algorithms. If our data is very huge, complicated, and our requirement is something, very critical to understand and to provide the output, then we will go for deep learning. So basically, machine learning versus deep learning is machine learning uses basic algorithms and a deep learning uses advanced algorithms. Advanced algorithms are also called as neural networks. You might have heard this word, right? Neural networks. Heard this word? Neural networks. These are nothing but brain again. Okay, brain of the network or the algorithms. So we will use advanced, these are also advanced algorithms that we will use in deep learning. In machine learning, we will use basic algorithms to train the data. So how exactly machine learning works? So is it clear what is machine learning? We are basically trying to train the machines by feeding the data, by showing them what are the patterns, and then we will collect the more information on that particular data. So let us understand now how exactly the machine learning works. This we already saw in a demo. Okay. Same thing. Internally, whatever we have seen in the demo, in the prediction of the Pongal traffic, right? Same thing behind the scenes. That is what is machine learning was doing. Okay. So what is the first step of machine learning is it will collect the data. So we have different types of data, right? We have different ways of feeding the data. We can have our own custom data, but generally we will get the data in terms of files in the file formats. It could be a Excel sheet, it could be a PDF, or it could be any other source. So what we do is for a machine learning algorithm, we will feed the data. So before that, what we do, we'll first analyze what is our problem, what is the requirement. Then we will get the data. So first step of machine learning to make it work is collection of the data. We will see the example, okay? So just try to understand the theory. These are, simple concepts. First, we need to understand the theory, okay? So the very first step is collecting the data depending on our requirement. Okay, here for example, say what is the collection of data step? Okay, just nothing but a student gathering information from textbooks and examples. Assume that student is a machine learning algorithm. Okay, so in that context, when we say data gathering or data collection, student is reading. He is collecting information from books and examples. He is collecting the data. Then what is the second step? Second step is finding patterns in the data. So ultimately, this is what machine algorithms does basically. Okay, its main job is to find the patterns in the data. What do you mean by pattern? What is a pattern? Can somebody type? This word we'll regularly use as long as we use machine learning. So what is a pattern? Pattern is a particular a structure or particular set of information, right? So machine learning algorithms will try to find out patterns on our data. Okay, we will see what is the example. By taking the example, we will see what is exactly means pattern, and how the machine learning is implementing these patterns. Then once the data is collected, once the algorithm is successfully find the patterns of the data, then it will test the patterns. Okay, so what exactly we can provide using these patterns? So internally, the algorithm will process those data to provide us a meaningful result. Okay, so that result is nothing but it will be dependent on the pattern that is collected by the algorithm. The set of a common information or common structure will be provided as output to the user. Then, of course, using it to make the predictions. So finally, the predictions will be made depending on the a pattern that is generated by the algorithm, and it will provide the predictions. Okay. So in just layman term, collecting data is in terms of students is nothing but he's reading textbooks and samples and gathering the data. Finding in patterns in data is nothing but whatever student has learned, he'll try to understand what is the context, what are the syllabus, or what are the different types of topics he has learned. Okay, that is considered as a training. In machine learning language, it is called as training the data. Training the data is nothing but processing. Okay, algorithms are trying to understand the data and trying to find the patterns in the data. Then testing the pattern. So once the student learned everything, he has to test, right? He should perform some self-assessment on his own. So that is nothing but testing. So how testing happens for a student? Obviously by writing an exam. Then finally predictions. Predictions is once he learn, once he test, once he assess himself, he will implement his knowledge in the real world. That is nothing but prediction. So if there is some requirement or if there is any problem, okay, he want to solve any issue, he will use his all the learnings, understand whatever he understood, then he will implement it in real life. So that is nothing but prediction in terms of machine language. So this data training, testing, prediction, these are all machine language terminologies. Okay, we are continuously use these terminology in machine language. Okay, repetitive data, training, testing, prediction, these are all will commonly use in our machine learning concepts. Any questions here? Are we good to go further? We are
Yes,
just
sir.
trying to understand what is machine learning. Okay, in just in a layman term. Okay, we are not discussing anything about algorithms and all. Just we are training. What we are doing, what we are achieving by using machine learning algorithms. Okay, so we are feeding the data to the machines using algorithms. Machine will analyze the data, try to capture the patterns, and they will predict something as an output. That is the main job of machine learning. Okay, now there are different types of machine learnings. The first one is called as supervised learning. And the another one is called as, of course, the opposite of that, unsupervised learning. Okay, supervised learning, unsupervised learning. So supervised learning, supervised, the name itself shows, right? Supervised means under some supervision, correct?
Hello.
Like a
So actually,
student,
voice is breaking. It's to me or everybody?
can someone confirm, please? Is my
It's
voice
clear for
breaking?
me. It's clear for me.
Okay. Sometimes it is like a blank for me. Not okay.
Oh, since when, Ramakrishna? Are you able to hear?
No, no,
Since when you are
yeah,
getting?
I'm able to hear you, but all of a sudden, I mean, I'm not hearing anything for a second, 2 seconds, then it's coming
Yes,
back.
sir. Exactly,
Okay.
but in the middle, for 2 to 3 seconds, it was just breaking your voice.
Oh,
I
okay.
thought
Maybe
it was
some,
my network issue.
yeah, sorry about that. Maybe my
That's
network
okay, sir.
issue
That's
here.
okay.
Right.
Okay, sir. Please continue.
Yeah, thank you. So there are two types of machine learning, rather three types actually. Okay, one is supervised learning, another one is unsupervised learning, and third one is reinforcement. Okay, supervised learning is nothing but like a student who is learning under the supervision of the teacher or a guidance. Okay, so machine learning, when it's trying to process any data under a supervised learning, they will have certain parameters inside them. So what is considered as supervised learning is when the model learns anything from the data, they will have certain parameters. They are called as labeled data. This is very important for supervised learning. Whenever you hear about supervised learning, you just understand it is a labeled data. Okay. Can someone elaborate what is labeled data? Looking at the example I'm giving, what is a labeled data?
Structured data.
Structured data.
Structured. Very good. Structured data. Okay. So looking at the data, we can judge or we can give a direct prediction. For example, in this example, okay, there is a score sheet summary, right? And looking at this score sheet summary, we can easily tell whether a student will be placed or not. Okay, it will be either yes or it will be a no. Okay, so the task is very easy in supervised learning. The data will be clear. Okay, there will be certain clear parameters depending on which the machine learning algorithms will easily predict, understand the pattern, and easily predict. Okay, what will be the output? And generally, supervised learnings are, you know, just a kind of output between two things. Okay, it is kind of boolean, whether true or false, yes or no, good or bad. Okay, the real time example, right? Every day we use our emails, and sometimes some emails will automatically go to spam. So how Google exactly is understanding so and so email should be sent to spam? Okay, so Google will have internally an algorithm. So that algorithm will check all your emails. Okay, whatever emails you are getting every day, Google will keep track of all those emails. It will look up certain things or certain words in that email. And if that word matches something related to spam contents, then automatically Google will send that email to the spam folder, right? it is our a regular everyday example. Okay, automatically our emails will go to spam sometimes, right? So how Google is doing that? So Google is executing internally certain machine learning algorithms. Those algorithms are trained to understand which is a spam email and which is not a spam email. Yesterday, yesterday, day before yesterday, okay, we have taken an example of a feedback form, right? If you all remember. So a feedback form ultimately contains what? A positive feedback or a negative feedback. So that feedback form example is a supervised learning example. So it will say whether it is a positive feedback or a negative feedback. How positive feedback we have discussed. How we can decide a positive feedback. Okay, positive feedback will have certain positive content, right, in the form, and negative feedback will have certain negative keywords that we can understand. Same thing, machine learning algorithms are also performing the same processing here. Okay, so the data will be trained in such a way that if there is some key content in the email, that is considered as spam. So Google automatically understands behind the scenes using the machine learning algorithms and send that email to spam folder. And all the normal other than spam emails, it will just send it to the respective folders. Okay. So this is a basic example of supervised learning. Usually supervised learning will be, uh, the predictions will be generally just it will be either true or false, yes or no, good or bad. We'll use such kind of predictions using the supervised learning. Okay, and we'll use respective machine algorithms for the supervised learning. So what it does, the problem statement is it will predict if the student will get placed in the campus or not. Okay, so using the supervised data, supervised learning, the machine will predict yes or no. That's it. It will not think much. So it will capture all this data. It will try to understand the pattern. Then it will predict. Okay. So what is the condition here? The model learns this way. Okay. If it is a high score with zero backlogs and good coding knowledge, he will be placed. So this is the logic internally. The algorithms will understand, they will process, and they will check these conditions internally. Okay, we are not giving any if else conditions to the algorithms. Algorithms are intelligent enough, they will execute by themselves. We will just provide the data. We will look into the data, we'll provide the data to the algorithms, and algorithms internally are intelligent enough. They will try to understand the pattern of the data. Okay, this is name, these are the marks, this is backlogs, these are scores. Okay, so they will analyze all this. Then depending on this, they will judge whether this guy will be placed or not. It will give the predictions. Again, it will be a prediction only. Just remember, it is not necessary that that is whatever it is predicting is correct. It will be considered only as prediction. So depending on the predictions, we human beings will analyze further and decide, okay, what that needs to be done. Okay, so these are all comes under predictions only. Okay, it's not like sure shot it will happen. Okay, even if you see ChatGPT or OpenAI, they will give one clause. Did you observe that one? Shall we see? Something
Yes, sir.
is with my machine. Okay. At least did this guy completion letter. Okay, let me do one thing. I'll take this one. Where do you see? Generally, they will say, right? Okay, here there will be some caption. Okay, they will say Chat GPT or Google, okay, can go wrong. Okay, just do your own analysis. So when we ask something right, here there will be a context given. What is another? Grok. What are all these which we are accessing? ChatGPT, Grok, Gemini. These are all LLMs we discussed yesterday. Okay, for maybe after hitting some query we'll get it. I don't know. What is artificial intelligence? Oh, sorry. I should go to Gemini. Okay. See, whatever I'm showing looks very simple, but they are the main things, okay, that we should observe and we should understand from that point of view. Okay. See here. Are you able to see my screen? I highlighted here at the very bottom. Gemini can make mistakes, so double check it. Okay. So they are providing us whatever they are able to provide, but at the same time, there is a small disclaimer here. Okay, they are saying Gemini can make mistakes, so double check it. What does that mean? So whatever he is giving here may or may not be correct. We cannot 100% rely on this information. We have to again reanalyze these contents. Okay, why this is happening? Any idea? Just random thoughts. This is all part of our subject. This is why we will work on our LLMs. There is one terminology called hallucination. When we talk about LLMs, when we learn about the transformers, we will understand more on this context. There is something called as hallucination. Okay, what it does is these LLMs, okay, they feel that they are intelligent. Okay, obviously they are intelligent, right? That's why they are providing us so much information. Sometimes they will show overconfidence. Okay, did you get the point? Sometimes they will show some overconfidence in providing the contents. They think that if I am not giving output to the user query, okay, user thinks something bad about me, that I am not capable. Okay. For example, shall we see did you understood what is this? Gemini can make mistakes, so double check it. That's what I was referring here. Okay. The whatever output will be there, they are just predictions only. It doesn't mean that these are the actual facts or results. Okay. Just we are trying to predict the information depending on our existing and past data. Okay. So coming back to this one, just I'll quickly show you. We have understood yesterday, right? What are LLMs? They are trained on huge amount of data across internet, across world, and using them, they are providing us all these contents. Now, I will give one simple query. Okay. Why the theft has happened yesterday, or let me read it. Why the Abraham Lincoln got killed when he was innocent. See, I have given some query. Okay. What LLM at the very first point thinks that it will try to process this. Okay. It will try to fetch the data across, the globe on whatever it is trained. Then it will try to form certain content. It will try to provide those data in a meaningful format, and it will try to provide some information to us. But in fact, the LLMs don't understand exactly the meaning of this query, what I'm giving. Okay. So let us see what is happening. I'll just hit. I just said why the Abraham Lincoln got killed when he was innocent. See, the way LLM starts, okay, if you understand, if you just read it, right, how it is starting? It is starting, thinking as if it knows everything. Okay, it is very brilliant, it is very intelligent, it knows everything. Okay, that is the way how it starts conversation with us. What is saying? President Abraham Lincoln was killed not because of any criminal guilt on his part, but because of political and see, it actually took my sentence. Okay, it is stressing on this part. I wrote why he got killed when he was innocent. Okay, so LLMs are starting using that particular context only. Okay, that is how LLMs behave. Okay, and after that, he's adding all rest of the key content that it pulled. Are you getting the point? These are all I don't need actually. Okay, I'm not interested in all this information. It is giving like the civil war happened, blah blah blah. I just ask LLM why Lincoln got killed when he was innocent. The LLM should give me a straight answer, right? But what it is doing, it is giving all sort of stories here. Okay, so that means LLMs predict. It will think that it knows much. Okay, and it will try to give some kind of output. So now we human beings will see, we'll look at the output and we'll try to understand, okay, if something is needed from this content, we'll take it. Otherwise, what we do, assume that we are storing this information in a file. What we will do, we will again retrain or clean the data and again retrain, again push back the query to the LLM by fine tuning the data, and we will again get back the exact answer that we want. Okay, that is what is called as fine tuning. We will just take the information, whatever is given at the first time, we will retrain using the cleaned data or the fine tuning of the LLMs. Okay, again, we will try to get the new results. You're getting? So in machine learning algorithms also, whatever we are trying to achieve, whatever the data we feed, they are just predictions only. So that is the whole point here. Okay, so we'll consider the predictions, but again, what we do, we will analyze it further. Okay, so this is what is a supervised learning. Supervised learning will be pretty simple. They will be having a labeled data and the predictions will be in a simple format. It will be yes or no. Okay, qualitative. They are called as qualitative data. It is yes or no. Clear? Any questions on this? Anything? Anything on the disclaimer that I showed you? Okay. So just don't take the contents as it is whenever you are doing any research. Just try to follow how much it is correct. Okay. Yeah. So under supervised learning, the example that we have seen is something called as classification, wherein there will be just two things, yes or no. Okay, whether the email is spam or not. Okay, whether the feedback is good or bad. Those type of requirements or issues or problem statements are called as classification problems. So using which we will solve the problem under supervised learning. So there is also something called as regressions. Okay, in regressions, there will be no labeled data. Okay, there will be just a data. So it does not show anything meaningful when we observe the data. Here, what is happening? When we see the data, we'll come to some conclusion. Okay, if this is the marks, no backlogs. If he is good at coding score, he will be placed. But if you observe this regression data, okay, there are different kind of bikes, their model number and their number of kilometers driven, of course, condition. Okay. But these data, looking at this data, we cannot predict anything much clearly. Okay. So depending on our different analytic capabilities, we will try to derive different solutions. But the machine language models, the machine learning algorithms use this data, they will process it using the regression models, and they will try to predict the output. So this problem statement is what we have to, the requirement is predicting the price of second-hand bikes, for example, say in OLX. So what we do, we will just give the data available on the OLX. We capture the data, we'll put it in a file. Okay, we'll pass the data to the algorithm. It will use internally the regression kind of algorithm, and it will predict as the price depending on the historical data. Okay, so these are, suppose for example 2020, okay, 2021, are these giving any special meaning, or will this have any special meaning in processing of the data? No. Okay, at least number of kilometers could be important, because it will decide the life of the engine, right? So that is how the regression model algorithms will take the data which are not labeled, and they will try to predict something. What is the prediction here that we are required? We are requiring, or we are expecting, the price of the second hand bikes. Got it? We will see further. Okay, once we go in depth in machine learning algorithms, we will see what actually exact algorithms that we use for all this. Okay, we have different types of algorithms. We will see why we use classification model, why we use regression model for our problem statements, what different types of algorithms we are using. Okay. Then under supervised learning, there are no labels here. Okay. And the model will try to find the patterns. Okay. For example, the example which you are seeing, right? Here it is given how many average amount spent in the canteen, or depending on average hours of sleep, or depending upon average number of hours spent on social media. Okay. The model is predicting whether these guys are belonging to this category, sleeping heads category, or canteen gan category. Okay, just a funny analogy there. Or they are normal humans. Okay. So in unsupervised learning model, we will provide the data using which the machine learning algorithms will try to understand the patterns, and they will predict depending on the data. So what is the category? What is the category of so and so persons who belongs to certain set of habits? Like for example, say if a person is sleeping an average of 8 hours, and he is spending money for some X amount in the canteen, and if he is watching average on the social media for 15 hours, it will try to understand the pattern of this particular guy. Similarly, all the other patterns the machine learning algorithm will search, and they will categorize these guys into different. Okay, for example, say Rahul and Neha belongs to one category, Sai and Ananya will belong to one category. Okay, so the unsupervised learning models, they will classify the parameters into different patterns, and they will classify them into different groups. Okay, we'll discuss this all again in depth, just for a just right understand this is what is a supervised unsupervised learning. Then we have something called informant learning. This is advanced one. Okay, we will take it when we are learning in the exact algorithms with examples. Yeah, any questions till now? on this? Anything? I didn't get any single question today. Any questions or any general questions can we take for a few minutes? Or can someone tell me what are the different applications that where we use machine learning algorithms? Yes, we are using in everyday life. What are the different applications we already discussed?
In social media, we are using the patterns like the unsupervised learning. I think it comes under unsupervised learning, like a
Right,
YouTube.
the social media, whatever we use, right? Facebook,
Yeah. So
everything.
what are the videos you are looking into it? So similar pattern will be coming in upcoming
R-
videos also. There.
Right. So what the algorithms are trying to do is they are understanding your the patterns. Okay, which context these guys looking more. What is the category of a subject he likes? Okay, so according to that, the algorithms will play a role behind that, and they will keep on providing you the same content. Very good. What next? Anything else? See, for example, if you try to apply a loan, okay, loan is a very good example again. So as soon as you apply a loan, there will be n number of factors that will decide by the bank whether a loan will be provided to you or not, right? So for a business person, there will be certain number of parameters. For a working guy, there will be certain number of parameters, deciding which the bank will use those parameters and decide whether this guy can be provided a loan or not, whether this guy can be provided a loan or not. So that all calculation behind the scenes is happening using machine learning algorithms only. You know, right? When we apply for any loan, we have to fill a form, and in that form, what is the very important thing? There are a couple of important things. Depending on us, that information, the bank will decide whether to give the loan or not. What are those important parameters? Can somebody quickly type in the chat? One is the very first important is salary, right? What is the monthly income? Whether it is above 10 lakhs, less than 10 lakhs, what is the range? Okay. What next? What is another important parameter? Come on, tell me. Never took loans, loan amount, good. And important is whether you are a employee or a businessman. So for employee, they'll be having certain different parameters to judge. For the businessman, they will have different parameters to judge. So like this, they will be having certain good number of parameters or inputs which bank will take. They will feed them everything in the system, and the system itself. When I say system, obviously nothing but a product, right, of their own. It will give the output stating that this guy X can be given a loan. So how exactly the system is deciding as soon as they are entering the data, depending on the information, depending on the inputs that we are giving. Okay. Venkatesh is asking if the outputs are not always correct. Why do we have to train by giving data and then get approximate results? Instead, we can do proper coding. Okay, there is a small catch. Okay. Finally, we are working. Venkatesh, good question. Actually, the outputs are not perfect or correct for the very first time. Okay. So what we have to do is we have to train the LLMs until we get perfect output. That is what is the job of a data scientist. Okay. Right. Correct. So first time, okay. See, today you are using Chat GPT or Grok. you are getting certain contents. But in the real time, see, these are all advanced models, what you are using. ChatGPT, Grok, Gemini, they are all advanced models, advanced agents, advanced LLMs that are fine-tuned, already fine-tuned. Okay. They were not like this when they initially created. Okay. There was a lot of data that got trained for the contents today that we are seeing. Okay. Even then, for example, Gemini is giving this disclaimer. Gemini can make mistakes. So what exactly that means is, see, it's something like this. At the very first time when they were creating these LLMs, okay, they struggled a lot. Okay, they did a lot of R&D. At the very first time, they were not getting the proper results. What we are seeing today, like this. What they did, they have trained their models, taking a lot and lot of data. See, it is as simple as that. Okay. In our childhood, suppose assume that we are trying to ride a bicycle. Venkatesh, when we are trying to ride a bicycle, what happens at the very first day? What we do? Immediately we cannot start, right? Immediately we cannot drive nicely. Okay, perfectly. What happens? We will fall down. We'll just drive for some, few meters. We'll stop. We will shake. Okay. All these things. Will you stop? No. You'll try again. You will fall down. You will get up. You will try again. You will drive again. So you will drive again and again and again until you learn how to drive perfectly. Correct? Same way, LLMs were also trained so perfectly that whatever you are looking now are they are well-trained LLMs. They are called as well-trained LLMs. They have huge amount of data that got trained behind these LLMs. See, writing LLMs is not a big deal. Even you can write your own LLM. Okay, what is an LLM? Large language model. What it is doing actually? You are providing some query. It is giving you the output. Can't you write this? We can write this. Simple example. Just think, in a layman's way. You are giving some query. It is giving you some information. Okay, when it is giving some information, it is trying to pull from somewhere, right? There could be some database behind the scenes. Okay. Yesterday, Venkatesh, were you present yesterday in agentic AI class? Let me show you one thing. I'll explain. That is actually a very good question. Okay. Hope you are all seeing my screen. Yes. So
Yes, sir.
yesterday, what we did yesterday, we tried to train our agent. Okay, taking a database. Okay. So Venkatesh, when I say when the inputs are the outputs are not correct, that means at the very initial stages, okay, the output will not be perfect. So Gemini is still thinking that whatever the results it is showing, right, they are still not correct, not precise. We are seeing it, right? By example, we are seeing it. My intention is just to know why this guy got killed when he's innocent, but it is trying to give me all other irrelevant information which I am not interested in. Okay, that means this is still needs to be fine tuned. Okay, so when Gemini was getting written, the LLMs when they were getting written, definitely this output was not the very first output that they might have got. Okay, they might have trained lot of data to get at least to this level of context. You're getting the point, Venkatesh. So what we will do is at the very first time, data will not be as good, the output will not be as correct as what we are expecting. So that is where we will go and fine tune the data. Okay, we will just try to repeat the data to be implemented again and again on the algorithms. Algorithms will have their own techniques. They will purify the data. They will try to reanalyze the output which is already given, and they will try to reframe the output. That is how recursively or iteratively again and again the data will be trained on the LLMs, and finally they will give this output. So when we are getting this output, right, it's not in a single shot actually. There will be lot of processing will happen again and again repeatedly on the LLMs. Then there will be a final output of this kind. Okay. So my statement of saying that the predicted data is not correct, that means they are not correct or not up to the mark for the first time. That is the reason why we need a data scientist to make sure whatever data we have today or whatever the data we have from the history, we have to fine tune all those data on our LLMs, and we should get a proper exact predictions. Again, we are using the word predictions because LLMs like Gemini are giving a disclaimer. So we are at the beginning. These guys are very, very advanced, but still they are giving a disclaimer that this can do mistakes. So when you are writing your own LLMs, definitely you are at the very beginning stage. We will work a lot on processing the data. Got it? So we cannot compete with LLMs by writing any code. No more coding. That is what all the the discussions that we did for last 3 days. Okay, there is no more coding. Everything is automation. Because of automation, AI is booming. And because we need AI, we have to learn data science. Okay. And this is the main reason. Okay. We need data analysts. We need data scientists. What is their job? I'll give example. This I already gave. Okay. I'll give my own real-time example. Okay. I'm working into a telecom company. So what is our job today? Okay. Our job is to understand the historical data of my company and to make sure how best we can improve our telecom business. Got it? As a data scientist, as a data analyst, my job is I have to fetch the historical data, I have to process the data, and I have to see. I'll query. Okay. I'll query means like my boss will query. Okay. We have our own custom LLM. We have written. Okay. Our boss will query the data. Behind the scenes, we have our own personal data of our company. So when my boss gives a query like this, he should get certain inputs from the existing data, which will show how he can improve the existing business. The data will be very, crude. It will be raw sometimes. Okay. So first time the prediction might not come correctly. The first time, whatever my boss wants to look into, the results might not be exactly as per his expectations. But it is job of us, data scientists, who will purify the data. Okay. Yesterday, day before yesterday, we have discussed all the data workflow. Okay. So we'll perform all those data workflow. We will use algorithms. We will make sure whatever is query is given, okay, it will result, most of the content should be perfectly reliable and useful for the customer or for the user or for my boss. Okay. So that is the gist of stating that predictions are not always correct. That is why I wanted to show you this statement here. Okay. Clear, Venkatesh? Any doubts? Definitely prediction will be a prediction. There is no doubt that they might be correct. Okay, it's like astrology. If somebody here believes astrology, what is astrology? Astrology is just prediction. However big astrologer is there, if he says something, we should not believe. Okay, he has his own LLMs, he has his own experience, he has his own data. Okay, he will collect the data from us, he will process his LLM and he will just predict it. So depending on your parameters, he can only predict. That is not 100% sure. Okay, right. Yeah, good question. Thank you. Thank you for bringing that question, Venkatesh. So we will fine tune. Okay, at the very first shot, we will not get the exact predictions. That is where we will use fine tuning. Okay, we'll just go and reiterate the model to work on the data again and again, unless we will get the output exactly as we need, or at least nearest to the output which we are expecting. Okay, right. Yeah, any other questions? Nice. Yeah. So one request, guys, please try to enroll yourself. Okay. Uh, Soon, probably, I think this link will be changed, and we will be landing into a new link wherein actual course will be started. Basically, I wanted to start at Python as soon as possible because that will take a lot of time. Okay. So we have to start as soon as possible. Please get get yourself registered. Okay, as soon as possible. Money has given. Money, can you please share more information for the students, maybe from your WhatsApp chat, or just provide them all the details. Guys, please requesting you, try to register, enroll yourself. Okay, so that we'll start actual our training as soon as possible. Okay. I think we are top of an hour, and we are good to understand the basics. We'll continue tomorrow again with more examples. Hopefully, I can, I'll try to show a demo again, like how we have seen for the Pongal travel predictions. I will come up with a demo, and tomorrow we can discuss on a live demo. I understand theory will be very boring, even for me also. So better we'll take an example. I'll show you a demo, and we'll try to understand exactly what are the rest of the concepts, like what is the machine learning cycle, how we'll perform it, how we'll perform our project using the machine learning pipeline. Okay, tomorrow possibly we'll just take a demo and we'll explain further. Okay, if there are no questions, again, kindly get registered yourself as soon as possible so that we can start the course. Okay, at the beginning, we'll start with Python. It will take time, minimum 1 month. So let's not waste time here. Okay, just try to enroll yourself ASAP. Yeah, if you have any questions, feel free to ask any question. I'm fine. No worries. Anything you can ask. You can spend 2 to 3 minutes. For any fees related, course content related or sharing related, contact Harsha Trainings, Money, and the team. There, they will WhatsApp you. Anything technical or related, to how we are achieving the course and all, we can discuss. Again, our course classes will be from Monday to Friday, sharp 8 o'clock, 8 to 9. If needed, we'll extend 10 to 15 minutes. Okay. And every day notes will be provided, assignments will be provided, video links will be shared. Everything will be there as it is. Yeah. Any questions, please? Okay. Thank you. Thank you all then. See you tomorrow.